Good morning. My name is Tim, and I'm one of the data scientists at Statsig. I'm here to share what we've learned from leading tech companies on how to scale experimentation. I'll sort of discuss what the best practices that they use, which I believe are going to be applicable for anyone doing experimentation, and how building a good experimentation platform truly democratizes data at your company. And what the sugar on top of all of this is that once you're in the experimentation space, this actually accelerates the pace of innovation at your company. But let me digress a little bit and talk a little bit about Statsig and who we are. Statsig, essentially, we are a product observability company. What that means is we provide our customers, who are product teams, with the same analytically aware engineering tools that power many of the large tech companies you know. The products we are known for today are feature flags and experimentation. And I think underneath the hood, what makes them special is that these are tools that not only democratize data, because data is a team sport, but these are tightly integrated into engineering workflows. And I'll talk a little bit more about that. But you'll notice that these tools change the way a company works. So this has meant that we aren't just selling tools, we're actually in the business of selling culture. Some key facts. We are based in Bellevue, and we're founded only in 2021, so we're 2 years old. And it was founded by a team of ex-Facebook product builders that believe very much in the data-driven product development philosophy. We have grown really fast. We're already serving hundreds of customers across thousands of experiments and billions of users. And some of our more notable fast-growing startup customers include the previous presenter, Whatnot, but also companies like Headspace, Ancestry, as well. I want to go over just a brief overview of product analytics, because that's actually my history and my background, but also the bread and butter of part of why we're all here. The foundation of this pyramid really is user analytics. This is the widest and also the deepest part of product analytics. It starts really with being able to define your KPIs and being able to just measure and track them, but it goes way deeper than that. It can get into understanding funnels, understanding user conversion rates, doing things like building LTV models, understanding drivers of retention. These are all wonderful and great methods that are all well known. But however, the real power to me, or the best tool in the product analytics toolbox, is experimentation. Now, and the reason why is that most tools in the product analytics toolbox are correlation-based, but experimentation is the gold standard for causality. The form of experimentation that most folks will know is the domain of website optimization. This is where you are largely focused on optimizing tactical metrics, such as this is the classic red button versus blue button. I need to drive click-through rates, or I need to increase sign-up registration flows. And this is largely a domain of marketing teams. Where we sort of differentiate ourselves is we are in the field of product experimentation. And the reason why product experimentation is a little different is that products and users and the way users interact with products is complicated. You need to be able to understand the holistic impact of your change. You'll need to be able to understand how that change affects your users day over day, what your users might be doing a week later. If you are Netflix and you're introducing gaming as a product, how does that affect your video? How does that affect people's usage on your movies and shows? How does that affect their renewal rates? These are things that are actually fairly deep and cannot be boiled down to a single metric. But even within this field, there is actually a group of companies that have taken this to the next level, and they are doing what I would call ubiquitous experimentation. These are companies that, these are companies that where the focus really is on the number of experiments they launch. And I'll quote a famous inventor, Jeff Bezos, who said that if you double the number of experiments you do in a year, you're going to double your inventiveness. Those are words that we believe to be very true. I'll drill in a little bit more about what these big tech companies are doing. They're doing something called modern experimentation culture, because when you are doing experimentation on this sort of scale, it fundamentally changes the way your company operates. Everyone knows what experimentation is, so I will define modern and culture. Modern. It's modern because products are complex. We are not just looking at click-through rates anymore. We believe experimentation cannot be boiled down to a single metric, and that you must have a holistic understanding of the experimental effect. This involves understanding multiple metrics. This involves understanding trade-offs and synergies. This involves understanding whether the effects you're seeing are novelty effects or whether these are going to be durable for the long term. Generally speaking, you want deeper, more meaningful metrics. Go back. No, I was on the right slide. You want deeper, more meaningful metrics, and you ideally business metrics when possible. But in terms of culture, this is the part to me where things get really special. This is all about experimental velocity and pace of innovation for these companies. In this sort of world, experimentation is a team sport. It's done by not just data scientists, it's done by engineers and PMs. Data is democratized. But not only that, in order to do this, data has to be pragmatic. Experimentation has to be pragmatic. That's why the integration into engineering tools is really critical. And experimentation at this scale, though, as I've mentioned, changes your culture. Your teams become metrics driven, information is shared, data is king, and opinions become far less important. I like this slide a lot. It's borrowed from one of our PMs. But when we talk to people who are looking at building an experimentation platform or looking to upgrade their platform, most people focus on the stats engine. These questions look like, are you using Bayesian or frequentist? Do you support the Mann-Whitney U-test? How do you handle peaking? How do you handle multiple comparisons? These are very important questions, but we have come to learn that this actually misses the mark on what causes experimentation programs to fail. Experimentation really is about your speed of innovation, your ability to test ideas quickly and get results. If your company is stuck in like having meetings talking about the proper design and setup of your experiment, if running computations is a manual effort and takes a lot of effort and resources from data scientists to try all sorts of fancy stats methods, and if it takes your team a long time to understand whether you're making the right decision or not, experimentation has now become your bottleneck, whereas the number of ideas you're testing should be. And so one of the hallmarks of these companies who are in the modern experimentation culture is that they test almost everything. I'll share a little bit of a story from my time when I was a data scientist at Facebook. I had an engineer come up to me. He made a one-line code fix. And it was very obvious in that code fix that there was an explicit typo, and he corrected the typo. And he asked me, should I set up this as an experiment? And part of me was like, not really, like this is clearly gonna work. But I said, like, you know what? At Facebook, the cost of setting up an experiment is near zero. It's trivial. And so I said, like, let's just run this for 2 days and see what happens. We ran it. The code worked. It fixed the bug. But what was very clear in the results was it introduced another bug downstream of that effect. And so like these sort of things are where like experimentation actually reveals things that you would not have necessarily anticipated. Is like really important. But that only happens when you can drive the cost of experimentation down to near zero, where it becomes automatic and part of the engineering process. Now I'll focus on experimentation best practices. There are a lot of blogs that have been published. There are even really good books on experimentation in the industry. But a lot of the practical aspects are sort of like locked up among these like top companies. So we do a lot of time and effort speaking with these experimentation thought leaders and experts and practitioners. And there are a few common themes that we have come to. Number one, like you've got to make testing easy. You've got to make it as simple to set up the experiment, and you've got to make interpreting the results almost as simple as monitoring a dashboard. You need to make experimentation self-service and democratized. I mentioned that it should be accessible to not just data scientists, it should be PMs and engineers as well. It's also really important to have a standardized methodology. So really, really good defaults, really good SOPs. And what this does is that if every team is not handcrafting their own experimental analyses, now results are suddenly comparable across the company. When a different team is talking about their results, what they did on revenue, you know that's comparable to another team's because they're using the same source of truth, the same statistical methods. They're using consistent, reproducible, and reliable methods, not handcrafted. I'll talk about a couple of the myths that we have come across that are very common. One is overlapping experiments. Companies tend to be very worried of when you're running multiple experiments now, how do those experiments interact? And this sort of interaction effect is actually highly overrated. For one, in my experience, like these things are fairly rare, and when they do occur, they're actually directionally consistent. But unfortunately, the real sinister part of this is that when you keep experiments apart from each other, you actually crushes your experimental power, the number of users you can put in, which kills your experimental velocity. The second myth is you don't need millions of users. I know we read about experimentation from these companies like Facebook who have like millions of users to throw at experiments. You don't. From what we have learned, the same tools can be used at experimentation from thousands to 10,000s of users. And I have a blog post that actually discusses why experimentation at that scale is more successful. Last thing is that holdouts should be automatic. I'm just going to give just an example of how we make experimentation accessible and intuitive like a dashboard. This is what a scorecard looks like on Statsig. We have here a list of metrics coming down here in rows. And we essentially do the statistical significance computation where if the lift is positive and significant, we color it green. If it's negative and significant, we color it red. And if it's statistically insignificant or not significant, it's in gray. This is very easy to understand. But DS in particular want access to details. They want to be able to deep dive into the nuances of the data. And to do this, we actually allow access to that. Back one. If you hover over any metric, we actually show you the breakdowns for test and control. Then there's this magical view details button, which shows you a lot more. And there's a whole bunch of stats underneath here. This one's my favorite chart. It's called days since first exposure. It actually tells you the experimental impact of a user when they're first in the experiment, their day 0, and how that trends over time. And so therefore you can understand whether it's a novelty effect or whether you can expect this effect to last for months. Talk a little bit about some of the lessons we've learned, at least on Statsig and our ability to scale. We talk a lot about speed and execution. These are values we preach to our customers and what you're buying, but it's also values we live by. So we have gotten to our scale by building quickly and getting quick feedback and tests done. Feedback, you say? That's where the customer focus part. This is where it helps us build empathy, really understand what our users are facing. We do something called customer delights, which is our ability to take the feedback, bug reports very seriously and build these features or be able to build features and fix problems within the span of days, if not even hours. What this does for an early stage startup is it really gets our customers to trust us and really gives them the belief that we can execute on our long-term vision. I'll give a call out for two sort of analytics functions and how we use them. For data science, having thought leadership, being able to get out there, talk about experimentation as experienced practitioners. This is something that our customers value a lot. It's also great for awareness and having discussions with the community. And the last thing is at the pace that we've grown, it's fair to say that at any point in time, our data engineering infrastructure will not last 6 months. So being able to redo all of that, being able to build good infrastructure, good scalability has been really critical for our success. This is my last slide. I love talking about experimentation, so please feel free to reach out. I've got some ways to reach me, although that one looks like cut off. But I'm also available after this. Finally, thank you for attending my talk.